At night, in cities across North America, something small starts testing the edges of the human world. A lid, a latch, a drain pipe cover, a loose board near the roof. To us, these are barriers. To a raccoon, they are questions. And if there is food on the other side, it will keep asking until the answer opens. Most people hear a raccoon before they see one. A sound on the roof, something rummaging near the back door, a lid hitting concrete in the alley at 2 in the morning. The instinct is to dismiss it, just an animal, and that instinct is exactly wrong. The raccoon is one of the most cognitively flexible wild mammals living this close to humans. From Toronto backyards to German rooftops to Japanese temples, it has found the same opportunity again and again. We build the barrier, and sometimes it learns the shape of the opening. Not because it is large, fast, or especially dangerous, but because it is patient, curious, and remarkably good at treating the human world as a series of problems worth solving. This is not a story about a pest. It is a story about what happens when a wild intelligence is placed inside a world designed for a different species and decides to stay. To understand how a raccoon navigates the human world, you have to start with its paws. A raccoon's front paws contain 5 flexible digits with no retractable claws, functionally closer to grasping hands than to blunt feet most mammals use for walking. They can rotate objects, pull on latches, press, probe, and grip from multiple angles. In 1907, a psychologist named Herbert Burnham Davis published a study titled The Raccoon, a Study in Animal Intelligence, in which he documented raccoons learning to open puzzle boxes that required them to work through several locks or steps in order. They were not neat laboratory animals, too curious, too restless, too difficult to standardize. But that was precisely the point. The same traits that made them troublesome in a research setting would later make them almost perfectly suited to the human city. What makes the paws remarkable is not just their dexterity, it is the sensory system running through them. A raccoon's front paws contain roughly 4 to 5 times more sensory receptors than their hind paws, a density of nerve endings that allows them to build a detailed tactile picture of any object they touch. This is why raccoons are often seen dipping food or objects into water before handling them. The behavior is called dowsing, and it has nothing to do with hygiene. A 1986 study published in the journal Somatosensory Research found that wetting the skin on raccoons' paws could dramatically increase tactile sensitivity, making those nerve endings more responsive. Water does not give the raccoon a new sense, it sharpens the one it already relies on most. A raccoon that douses an object in water before examining it is not cleaning its food, it is turning up the resolution. This matters because their night vision is useful, but touch gives them information their eyes cannot. The paws become their primary instrument for reading the world. The shape of a latch, the weight of a lid, the give of a container flap. They explore through touch the way other animals explore through sight, which means that every new piece of human infrastructure they encounter, every bin, every door, every mechanism we design gets read the same way, carefully, patiently, with hands that are better at this than we tend to assume.
Here is what a city looks like from inside a raccoon's territory. A dense, warm, permanently stocked environment full of interesting problems. Garbage bins, drain pipes, roof vents, pet doors, compost containers, loose fence boards, dumpster lids, outdoor storage boxes. All of these are, from the raccoon's perspective, potential food sources separated from it by varying levels of difficulty. And raccoons do not seem to treat difficulty as a stop sign in the way many animals do. They investigate new objects, they test, they try different angles, they come back. Researchers studying urban raccoons keep finding the same thing. These animals do not move through cities randomly. They learn where food appears, which routes carry danger, which structures can be climbed, which obstacles are worth revisiting. Some experts have suggested that raccoons may even pick up on the rhythms of garbage nights, not as a calendar, but as a pattern in neighborhood behavior. Whether every animal tracks this consciously is difficult to prove, but their movement patterns in tracked populations show something clear. They are not wandering. In Toronto, a city with an ongoing and very public history of losing to raccoons, the municipal government introduced a new raccoon-resistant green bin in 2016, requiring a two-step manual operation to open. A raccoon does not need to understand what a garbage bin is. It only needs to learn that this corner moves, that this lid has weight, that this latch gives way if pulled from below. Within months, footage of raccoons working through the new mechanism was circulating online. Toronto had built the bin for raccoons. The raccoons had started studying the bin. Suzanne McDonald, a psychology professor at York University who has studied urban raccoons for years, placed secured garbage cans baited with cat food at sites across Toronto and rural Ontario. Urban raccoons opened the cans. Rural raccoons, encountering the same puzzle for the first time, largely did not. McDonald described the city as an accidental classroom, a place where raccoons are continuously presented with new problems and where the animals that solve them eat better, survive longer, and raise more offspring. Every lock, lid, drain pipe, fence, and trash bin becomes a test. The city is not just habitat, it is selection pressure. One of the most counterintuitive findings from raccoon research is how little space an urban raccoon actually needs. In forests and rural areas, raccoons' home ranges can cover several square kilometers. They move seasonally, follow food sources, use large territories. When researchers fitted urban raccoons with GPS collars and tracked their movements in detail, collecting up to 1,500 position readings per animal over several weeks, they found something quite different. Urban raccoons were operating in surprisingly small territories, sometimes only a few city blocks. They did not always need a stream, pond, or obvious natural water source inside the territory. They used whatever structures were available for shelter: attics, crawl spaces, storm drains, dense shrubs, abandoned buildings, and rotated between several resting sites throughout the study period. The one consistent boundary the researchers identified was major roads. Raccoons avoided crossing high traffic streets, not because the roads blocked them physically, but because they had apparently learned to treat them as dangerous. They navigated the city's infrastructure the way they navigated everything else, through observation, caution, and a working model of what the environment does. This is not a forest animal making do in an urban landscape. In many neighborhoods, the city supplies the same basic needs: food, shelter, water nearby, roots through cover, in a dense, predictable form. The wilderness is not waiting for it to return. In many cities, the calculation has already changed.
The uncomfortable possibility is that we are not just failing to stop raccoons. We may be giving them better tests. Every time we design a new raccoon-proof mechanism, we present the urban raccoon population with a new problem. Most individuals fail it. A few do not. The ones that solve it eat more, survive better, and raise more offspring. Their offspring, growing up in an environment where that mechanism is normal, encounter it younger and have more time to learn it. Over generations, the population may shift, not through genetics alone, but through survival, learning, and young raccoons growing up beside adults who already know how the lid opens. Evolution does not need every raccoon to solve the bin. It only needs the stubborn ones to get fed. McDonald at York University has described this dynamic directly. The more obstacles we put in their way, she has argued, the more we may be pushing the cognitive development of the urban population. She has used the phrase uber raccoon in media discussions, not as a sensational claim, but as a way of naming what directional selection might produce over time in a mammal that is already unusually flexible. We are not just living alongside raccoons, we may be building the problem. The reason raccoons make terrible pets is the same reason they do so well in cities. In 1926, President Calvin Coolidge received a raccoon sent to the White House as a Thanksgiving dinner contribution. He named her Rebecca, gave her a small enclosure on the grounds, and walked her on a leash. Like many tame raccoons, she investigated everything within reach, got into spaces she was not supposed to enter, and was eventually relocated to a zoo. She was described as charming, exhausting, and impossible to contain. What the Coolidge household encountered was not a problem raccoon. It was a raccoon doing exactly what raccoons do, using its hands, its curiosity, and its persistence on everything within reach. The intelligence that makes them successful outside the house makes them genuinely difficult to manage inside it. Not because they are unusually aggressive, but because their curiosity never really turns off. A more consequential version of this misunderstanding played out in Japan. In the 1970s, a popular animated series called Rascal the Raccoon sparked a wave of imports. At the peak of the craze, Japan was reportedly bringing in as many as 1,500 raccoons per year. As the animals matured into the adults they were always going to become, most were released or escaped. Japan had no native raccoon population and no native ecological system prepared for an animal like that. Today, raccoons are present across all 47 of Japan's prefectures, classified as an invasive species, and have caused documented damage to historic wooden temples and traditional architecture that takes centuries to build and minutes of motivated paws to damage. The entire situation began with a cartoon and with a misunderstanding of what raccoon intelligence becomes when it is released into the wrong world. Across North America, raccoons have become one of the most familiar wild mammals in human neighborhoods. They are established beyond the continent now, in parts of Europe, in Japan, in places where people once brought them as pets, curiosities, or fur animals, and where they found that human infrastructure suited their particular set of skills disturbingly well. We designed the bins, the drains, the attics, the scheduled collection routes, the pet doors, the composters. We engineered the locks. Raccoons engineered nothing. They simply paid attention to what we built and worked out how to use it. And each new generation begins in a city the previous one has already been testing. The raccoon is not trying to become human. It does not need to. It only needs to understand enough of our world to keep taking from it. And that, in the end, may be the most quietly unsettling thing about it. Not the noise on the roof, not the overturned bin, but the fact that an animal this small, this common, this easy to dismiss, has been patiently learning the shape of the world we built, one latch at a time. Every obstacle we build becomes a lesson, and raccoons have had a long time to learn.